Morning. Today we are here to study about unit level heat topic, that is specific heat activity 6 we are going to study. Before that, let me recapitulate what we have studied. Within specific heat only, we have completed activity 5. That activity 5 is based upon the nature of material. How it depends upon the nature of material, we have completed that activity. Specific heat of a substance depends upon nature of material, we have completed. Within this activity 6, we are going to discuss that specific heat of a substance depends upon two different quantities, that is, one is mass of a substance, other one is temperature. Individually we are going to frame a relationship. Specific heat of a substance is depending upon mass, it has one relationship. Similarly, depending upon temperature, it has its own relationship. How that relationship exists, that particular concept can be explained clearly by using activity 6. Let me go into this particular activity 6. First of all, take two beakers of equal volume. Then afterwards, in first beaker, fill it with 250 grams of water. Similarly, second beaker also, fill it with 1 kg of water just to fill it up. After filling it up, at equal interval of time, heat gently these two beakers till they attain temperature of 60 degrees centigrade. Till they attain temperature of 60 degrees centigrade, heat these two beakers at equal interval of time. Before heating, note down their initial temperatures. Their initial temperature will be at water, a room temperature, it will be existing. Later on, heat it gently at equal interval of time until it attains a temperature of 60 degrees centigrade. Observe it up. Now question arises in our mind. What is that question? Which beaker needed more time? You said clearly there itself. It is having 250 grams of water. It is having 1 kg of water. Among these two things, which beaker will be having needed more time than itself? Which beaker will be attain 60 degrees centigrade? More time is needed than itself. By seeing clearly, we can say that in which beaker there is more mass. A beaker in which it is having more mass will need more time interval to attain 60 degrees centigrade. Among these two things, for example, if I am taking A beaker as well as B beaker is having 1 kg of water. To attain 60 degrees centigrade temperature, it needed more time interval. More time is needed to attain 60 degrees centigrade temperature. To attain constant temperature of 60 degrees centigrade. By this, what we can understand that itself, rising temperature of 1 kg of water, you have taken here there itself. Rising temperature of 1 kg of water is more, it will take more time than that of rising temperature of 250 grams of water. That particular point we can understand. What is the point? Rising temperature of 1 kg of water needed more time interval than that of rising temperature for 250 grams of water. By this, what we can understand? We need to supply more heat for this particular 1 kg of water. For 1 kg of water, we need to supply more heat than that of the quantity which is having less quantity of water is existing. By this thing, we can frame a relationship. What is that relationship? Heat absorbed by a substance, heat absorbed by a body either a body of 1 kg mass or a body of 250 grams is directly proportional to the quantity of mass. How much mass we are taken, it is directly proportional. Heat supplied to this particular body is directly proportional to the quantity of mass. Heat absorbed by a body is directly proportional to the quantity of mass. If more mass is there, more time it is needed to attain temperature of 60 degrees. If it is less mass, less time is needed to attain temperature of 60 degrees centigrade. By this we can frame a relationship. That relationship is quantity of heat absorbed by a body is directly proportional to the quantity of substance we have taken, and at what temperature? Temperature is constantly. To attain 60 degrees centigrade temperature, if one body is of higher mass and if another body is of lower mass, higher mass needed more time interval than that of lower mass to attain the temperature of 60 degrees. By this we can say that if mass is more, heat absorbed by a body will be more. If mass is less, to attain 60 degrees centigrade, heat absorbed by a body will be more. If mass is less, heat absorbed by a body will be less to attain temperature of 60 degrees centigrade. By this, we got a relationship that is nothing but what? Quantity of heat absorbed by a body is directly proportional to the quantity of mass of a substance. How much quantity we have taken, that relationship we have taken it up now. Now coming to next one word regarding temperature. Now we frame another one. Okay children, just now we frame a relationship with specific heat, or within specific heat the quantity of heat absorbed by a body is directly proportional to its mass. That is, quantity of heat absorbed by a body is directly proportional to mass. To attain constant temperature of 60 degrees, we have said it up. At constant temperature, quantity of heat absorbed by a body is directly proportional to its mass. If more mass is taken, more heat it is absorbed to attain 60 degrees centigrade. If less mass is taken, less heat it is absorbed to attain temperature of 60 degrees. We are seeing clearly. Now next one is what? Specific heat of a substance related to temperature. It is also related to temperature there. How it relates? Let me do it up there. To perform that particular concept, I have taken a beaker of unit volume, of same volume. Within that beaker, I have taken 1 liter water. 1 liter of mass. I am maintaining mass is equal to what? A constant of 1 liter only. Then afterwards, I take a spirit lamp or anything else, heat gently at constant flame. Heat gently at constant flame. As we are heating gently at constant flame, what happened? We know that temperature, just check it up, note the temperature rises for every 2 minutes. Check it up. For every 2 minutes, how the temperature rising will be that existing, just you observe that itself. What you will notice? Will notice that change in temperature for every 2 minutes, certain change in temperature can be applied. For first 2 minutes, if temperature is of attaining 30 degrees, next 2 minutes, little bit more than enough 30 degrees, temperature will be getting increased. We can see that by that particular point, we can say that change in temperature rise is directly proportional to the we have taken here as what? Same quantity of mass we have taken is directly proportional to the heat absorbed by that particular mass of constant mass we have taken. Change in temperature, that means what temperature is rising or falling. Rising temperature is directly proportional to the amount of heat absorbed by same quantity of mass. Therefore, we will frame a relation that is nothing but what? Quantity of heat, the amount of heat absorbed by body is directly proportional to change in its temperature, and where mass is remaining as what? Constant. This is considered as what? Second relation. Already we had first relation. Quantity of heat absorbed by a body is directly proportional to its mass at constant temperature. From 1 and 2, we frame relationship. Quantity of heat absorbed by a body is directly proportional to product of mass. The quantity of mass were taken and change in temperature. Therefore, if I remove this proportionality constant, Q is equal to S into M into delta T, where S indicates specific heat of a substance which depends upon nature of material, M indicates mass of the substance, delta T indicates change in temperature. From this thing, if you want to measure specific heat, S is equal to Q by M into delta T. That means what? The amount of what is specific heat? Specific heat of a substance is nothing but what? Amount of heat required to rise temperature to 1 degree centigrade per watt mass, unit mass of a substance for how many unit? A unit there itself, 1 unit. Amount of heat required to raise the temperature per 1 degree centigrade of unit mass of substance is nothing but what? It is called as specific heat. And what is and its units already we have discussed clearly. By this we have completed activity 6, and within this activity little bit more information we can analyze it up in Let me check the class. Just now we have completed activity. Within activity 6, we have completed one concept, that is nothing but what? Quantity of heat absorbed by a body is directly proportional to mass of the body as well as change in temperature. If you frame the relationship, Q is equal to if you remove this proportionality constant, I will get Q is equal to S into M into delta T, where S is called as specific heat of a substance, as we are dealing with the specific heat of a substance there. Therefore, S is directly proportional to quantity of heat produced and inversely proportional to mass of the body as well as change in temperature. We have seen clearly that the nature of S indicates for specific heat of a substance depend upon 3 factors. One is nature of the substance, second one is change in temperature, third one is mass of the substance. Therefore, this specific heat depend upon, we know clearly that rising temperature mainly depends upon nature of material. Depending upon the nature of material, temperature rising can be taken place. If you go for some materials here, such as lead, mercury, brass, water and seawater, if you check it up, specific heat of the substance of lead is in CGS system it is 0.031, in MKS system it is 130 joule per kg Kelvin it will be there. Mercury if you go it up 0.03333, or if it comes to SS system 139 we can give it up. Brass 0.92, 0.092. If it comes to SS system, it is 380. When it comes to water, in CGS system, its value will be equal to 1 calorie per gram degree Celsius. In MKS system or SS system, it will be 41800 joule per kg Kelvin. When it comes to seawater, it is 0.95 calorie per gram per Celsius in CGS system. In MKS system or SS system, its value will be 3900 joule per kg per Kelvin. Among all substances, if you go into specific heat of water is greater than that of all the substances. And also, specific heat of a substance, if you frame a relationship here, specific heat of a substance, as we are dealing with the temperature as well as nature of substance, it is inversely proportional to temperature. If specific, by this we understood clearly that if specific heat of a substance is high, if specific heat is high, the rate of rise or fall of temperature will be low. By this we can give, we can see one idea. That idea is nothing but it comes to an idea that it gives an idea of degree of reluctance. What does it mean? It is nothing but unwilling to do something there itself. As specific it is high, temperature is not doing anything else. Temperature is not rising at all. It is decreasing. Not we don't want to perform. We don't want to increase its temperature there itself. We have seen clearly within this particular specific heat. If specific heat of a substance is high, temperature is remaining as low. And we have seen clearly here also specific heat of water, if you compare it up with among all materials, it is high. If it is having high, obviously temperature will be low. It can lower the temperature also there itself. And one more question will come across. What is that question is, why do specific heat differ from different substances? Why it is differ? If you say the nature of material, lead is of different material nature, mercury is of different material, brass is of different substance, water is of different substance, seawater is of different substance. Each substance is consisting of what? Some energy particles. These energy particles means what? And we know one relation. Kinetic energy of particle is directly proportional to temperature. And kinetic energy of particles will have different types of energies, such as linear kinetic energy, potential energy, rotational energy, vibrational energy, etc. So on, different types of energies will be existing within the molecules. If you take a molecule, within that particular molecule, linear kinetic energy will be existing, vibrational energy will be existing. Simultaneously, potential energy can be existing, rotational energy can be existing. When we are supplying heat, these are all substances, these are all energies. Linear energy, rotational energy, potential energy, as well as vibrational energy, they all gain that particular energy with the different ratios. As they are gaining that energy different ratios, these all energies will be existing within a molecule internally. Therefore, together we can call it as one energy. That energy is nothing but what? Internal energy we can give it up. By this, as heat is supplied to any molecule, what happened there? All the molecules will be having different types of energies. Linear, vibrational, rotational, potential energies. So, heat will be shared by all the molecules. Within that molecules, what? Linear will be different energy. Vibration is different, rotation is different, potential is different. Therefore, having different energy molecules. If heat is supplied to any other object, if you are applying heat for any other substance, it absorbs that heat. As the molecule is absorbing heat, that observation will be indifferent within the molecule as they consist of different types of energies. So that it varies from substance to substance. We are talking about different substances. Lead is a different material, mercury is of different material, brass is of different material, water is of different material, seawater is of different material. So rising temperature of any substances is nothing but what? Mainly it takes place depending upon maximum share of heat energy utilized by kinetic energy, that of linear kinetic energy. Rising temperature of substance can be mainly identified by one property, that is nothing but what? Maximum share of heat energy can be supplied by means of linear kinetic energy. It will be utilized. So that it will be varied from different substances. Lead is a different, brass is a different, so that heat also will be varies for different substances. Depending upon that nature, what happen, different substances will have different specific heats. By this we have completed our activity 6. Within this activity 6 also, by based upon the specific heat concept, we are having certain applications where we can apply these all things. First one is what? If we go for our earth, applying here what? Earth. If you see our earth is consisting of how much? Earth will be existing in spherical shape. As earth is a existing in spherical shape. Center of the particular line, if you take it up, it is having 0 degrees centigrade with 0 degrees, which is called as equator. In social, we have seen clearly that it is divided into different regions, such as Tropic of Cancer, Tropical of Capricorn, as well as Tundra region, so on, Equator region, Tropic of Cancer, Tropic of Capricorn, Tropic of Cancer, Tundra regions or pole regions. You can take it as what? Here it is a North Pole and here it is a South Pole. If you observe that it's a Peter and this earth is covered with 70% of earth is covered with water. First application. If you observe on surface of the earth, temperature is falling on the earth at different regions with the depending at equator high temperature will be there. At tundra region it will be very cool temperature. Yes or not, children? But as we are having earth is covered by 70% of water, when the sunrise is falling on surface of the earth, we know that specific heat of water is greater than that of any other substance. So these water is existing in the form around the earth in the form of what? Oceans, lakes, rivers, etc. so on. So maximum quantity of water is covered around the earth. So that what happened there itself, when sunrise is falling at equator when sunrise is falling, heavy temperature will be existing. The total temperature which is coming from the sun will be absorbed by the ocean. Therefore, oceans can be called as nothing but what? Hot sources we can call it. A hot heat sources of that particular body we can call it. That heat which is absorbed by the water will transmit it equally. High temperature is existing, it transmits equally around the earth by observing that particular to moderate the temperature. That's the reason at equator also, if sun is near to the equator, if temperature is very high also, there within that region moderate temperature will be existing. Why? Here water is playing as nothing but what? A major role, whose specific heat is high, and it will behave like as nothing but what? Hot store houses it will behave it up. Due to that reason, around the surface of the earth, temperature will be remaining as what? Moderately. That is the first application of specific heat we can give it up around the earth. Temperature is remaining moderately around the earth. That is first one. If you take the watermelon and we place the watermelon in a fridge, you take out the watermelon outside. After surface, you touch it up. After few minutes, you touch it up outer surface. It won't be that much cool. But you cut the watermelon. And if you cut it them into pieces and try to take one slice, try to eat that particular watermelon, our teeth will experience a lot of coolness. Why? Means what? It has high percentage of water inside it. That is also one more example. Outer surface is cold, interior surface is a little bit much more cooler than that of outer surface. It also depends upon what? Specific heat of a substance we can give it up. Third one. If you go for daily days to eat samosa, if you go for any hotel or else any bakery, we can see they will be placing some samosas in a tray. If you touch the particular samosa from top, we will feel little bit cool and we will take it up and we will eat it up. As we are eating, what happens that the hotness of samosa inside the material, inside the samosa, the curry what else it is existing, it will be little bit hot. Why? It is made up of different ingredients, either by using potato or by onion or by carrot. Different materials, different ingredients they are using it up. Each substance is consisting the quantity of water percentage existing in that one. Due to that reason, samosa if you touch it from outside it will be cool, inside it will be hot due to various ingredients of water quantities existing. Due to that reason, specific heat of water is higher than that of any other substance. All the ingredients consisting of water, due to that reason, samosa appear hot for us. By this, we have completed our total concept called as specific heat. Thank you children for watching. Try to analyze the concept much more clearly by watching number of times and try to get clarity regarding this topic. Thank you. Thank you, one and all. Within this particular specific heat concept, let me go for a worksheet. How the worksheet would be? Directly you may ask, define specific heat of a substance. Or what are the units of specific heat of a substance in CGS system as well as MKS system? For 1 mark they can ask. Similarly, he may ask, frame a relationship between CGS system as well as MKS system units, relationship you frame it up. He will ask for that question for how many marks? 2 marks question he can ask. Simultaneously, coming to 4 mark question, 2 questions, activity 5, activity 6. These 2 activities can be asked in the form of 4 mark question there. Determine what is activity 5 gives information. It gives information about what? Specific heat of a substance depend upon nature of material. How it is depending upon the nature of material, that concept you will ask it up. Determine how the specific heat of substance depends upon nature of material. Direct question for 2 marks. Next one is what? Determine how the specific heat of a substance is proportional, is depending upon mass of the body as well as temperature of the body, temperature. That a question also you can ask for 4 marks. Not only that one, within this particular concept only, why specific heat of a substance is differ from different substances. That particular concept. Why specific heat is different for different substances? For 2 marks question you will ask it up. Due to consisting of linear, rotational, vibrational as well as potential energies. And next one is our last question. Write some applications of specific heat of capacity. We have seen 3 applications. That is earth surrounded by water. That is one as water is having high specific heat than that of any other substance. It can be get cooled soon, it can be get absorb more heat there itself. You have seen clearly. Therefore, if you concentrate on these all questions, what type of question you will ask regarding specific heat, you can secure 100% marks. All the best. Prepare well for exam. Try to analyze the answer based upon this questioning and try to get good marks. Thank you.